you guys, this is Mrs. Boland with your notes for section 6.3 on Scatterplots. So we're going to be going through the warm-up today, and thankfully this is a lot easier than the last few that you've been doing. So after the warm-up, we're actually going to use some technology to help us do these problems a little bit easier. So for question number 1 on the warm-up, it says, use the scatterplot to answer these questions. What is the grade point average of the student who spends 6 hours a week on homework? So here's 4 and 8. So right in the middle would be 6. So there's that student's GPA point. So I'm going to trace it over to the y-axis, and that student has a 2.0 GPA. Question number 2, how many hours a week does the student who has a 2.75 grade point average spend on homework? So if I look at 2.75, well, this would be 2 and 3. This would be 2.5, so 2.75 would be right in between those. How long do they spend on homework each week? Well, it looks like 12 hours. Okay, so when we're looking at scatterplots are real-life data where we have some sort of input and output or two different variables, and we want to see if they are related or not. It doesn't necessarily mean that one causes the other, but we want to see if there is some sort of relationship, if there is a correlation between these two different variables. So if the points as x goes up, y goes up, if they travel together, that's a positive correlation. So for instance, as x goes down, y goes down. So they either both go up or both go down. They travel together. That's a positive correlation. The slope of that would be positive. The correlation is positive. If as x goes up, y goes down, so x is going up, y is going down, that's a negative correlation. As x goes down, y goes up, right? So the other way around, if they're going in opposite directions, that's a negative correlation. If they are all scattered all over the place and there's not really any pattern at all, we say that there's no correlation. All right, so we are going to be using Desmos, our online calculator, to find a line of best fit. So we're going to do that in just a minute. But first, we're going to look at a couple problems. And this first one, it says, tell whether the data shows a positive, negative, or no correlation. So looking at this, it's kind of all spread out. Is the line going up? Is it going down? Who knows? So we would just say no correlation, or I would even say none. There's no correlation up there. Okay. The temperature and the coat sales at a store. Okay, as the temperature outside goes up, the average daily temperature, what happens to the coat sales? The coat sales are going down, okay, right? As one goes up and the other goes down, we say that has a negative correlation if they go in the opposite direction. You can also look at it left to right, and that is going down. Like if we're playing chutes and ladders, that's a chute, okay? Or slides and ladders. I think somebody said they changed the name of it. Anyways, this would be a negative correlation. Okay, for question number 3, it says the table shows the weekly sales of a DVD and the number of weeks since its release. Write an equation that models the DVD sales as a function of the number of weeks since its release. Interpret the slope and the y-intercept of the line of fit. So the first week out, they sold a bunch of DVDs. After it was out for 8 weeks, not quite as much revenue. And realize here, you guys, they didn't make $6. They made $6 million. Those are in millions. Okay, so we're going to go over to Desmos, but I want to point out a few things. All of the instructions are right here. This is the website you go to, desmos.com. You click the plus, and we're going to add a table. We're going to put all of the data in there, making sure to be careful what's X and what's Y. We're going to zoom plus with the little magnifying glass there. And then in slot 2, we're going to type that right there so that it gives us an equation of the line of best fit for all the data that we enter. Okay, so we're going to go ahead and switch over to Desmos. And this is what it looks like. You're going to go at the top where it says Math Tools. You guys are going to go to the graphing calculator. You could also click right here where it says graphing calculator. I just want you to see that it does have other tools here as well. So if you needed square roots or other scientific calculator type things, exponents, that's where you would go. We're just going to go on the graphing calculator. And then remember, our instructions are that we go to the plus sign. So we're going to add a table. And so our first x value is 1. Our first y value is 20. And then we're going to enter those in here pretty quickly. 2 and 14. And we have 3 and 13. You guys should be trying this on your own just to make sure that you get the same results that I do, because you will need to use this on your quiz. 5 and 10. And then 6 and 8. 7 and 9. And 8 and 6. Okay, so once you do that, the next thing said to go Zoom Plus. Oops. Where is the little plus? Is it hiding under there? Why can I not find this? Oh, it's hiding over here. Oops, there we go. Okay, there's the Zoom Plus. It wasn't showing up for some reason for a while. Okay, so the next thing we're going to do is right below that, we're going to enter this y1, and then we're going to put in the little squiggly thing. And then we have mx1, and then plus b. All right. And so now it tells us what m and b are. So you can write that equation down. So I'm going to write it on my notebook, and then I'll put it back up there for a minute. So y equals the m, and we'll just go to 2 decimal places, negative 1.63. And then we're going to put the x. And then for the b, I'm going to go to 2 decimal places again. So 18.46. And remember that you're always rounding. Okay, so let's switch back to the notebook for a minute, and then we're going to come back to Desmos again. Okay, so you can see right here is where I wrote my equation that we got from Desmos. So now we're going to go over to your assignment. Question number 1, it says use the scatter plot to fill in the missing coordinate of the ordered pair. So this one I have the x value is 16. So I'm going to find the y value. If I trace that over, my y value is 6. If the x value is 3, oh, sorry, that's 4, just kidding. They're going by 2s, so the 3 would be right there. The y value would be 14. Now this time I have a y value of 12, and then I need to find the x value would be 7. And then when it's 17, that one would be 8. All right. Question number 2, you can try on your own. You're just going to say whether there's a positive, a negative, or no correlation. Question number 3 would be no correlation. Question number 4, you can do on your own. What type of correlation does it have? Question number 5 says the table shows the total earnings. Use Desmos. We're going to use Desmos. Oh, and I forgot to interpret this, you guys. This would be the starting amount, like in 0 weeks, and then, which doesn't really make a ton of sense in the context of this problem. Or maybe that's just what they made initially. And then this would be, it would go down by 1.63 million each week. So that's what the slope represents. This is their starting income. And then each week it goes down a little bit, a little bit, a little bit as it gets farther away. Okay, so we're going to do the same thing when we plug this in. This is the total earnings in dollars of a food server who works 8 hours. So you can, or sorry, X hours. The more hours they work, the more money they make. All right, so we're gonna put that information into Desmos. So we're gonna go back over there. You're gonna do number 6 on your own. So make sure you're really, really paying attention for number 5. And hopefully I'm able to find the right buttons. Okay, so I'm gonna turn that one off. I'm going to add a table. I'm gonna get rid of that one too. Okay, so I'm gonna put the table in. Actually, let me just refresh that so that we have x1s and y1s again. Okay, so for the x value, we have 0, and the y value was 0. So that makes sense. They've worked 0 hours. They make $0. All right, 1 hour, and we've made 18. 2 hours, and they've made $40. 3 hours, and they made 62. 4 hours, and they've made 77. And then 5 and 85, and 6 and 113. Okay, and then here's the plus. I don't know why I couldn't find it last time. It was hiding from me. And then we're going to type in this below, y1 squiggly. That's the official math word for that. mx1, and then plus b. All right, and so again, here is our y-intercept, and here is our slope. So for letter A, it says use Desmos to find the line of regression. And so we're gonna write the equation for that. So y equals, the m would be 18.21, x, and then the b would be 1.79, because we're gonna round it up. All right, so we're going to go back over to the workbook. Sorry, let me zoom in again. All right, and so here's what you guys should have. Here was the equation that we found, and then where it says interpret the slope and y-intercept. Well, the slope is right there, and that's the waiter gets $18.21 for each additional hour worked. Okay, and then in the context of this problem, this doesn't make a ton of sense, but that would be the amount of money they would make if they worked for 0 hours, which in this case, you would get $0 for 0 hours, but that's what that represents, is when 0 hours, they would make $1.79 earnings. Okay. Yeah, and so that would be the interpretation of the slope and the y-intercept. This one is very close to being 0. So essentially, you could kind of consider it very close to 0. You're not going to make much money if you're not working much time. And then each additional hour, that's a pretty nice hourly rate there. So you guys are going to try number 6 on your own using Desmos to find that equation for you. That is it for your notes for 6.3.